12.2 Day 4, Example 1, letter E. The other situation we're going to look at with these rational functions is a problem like this one. Everything is going to be the same all the way through the whole problem, just like we did in letter D, except at the very end, we're going to have a little different scenario to look at. So, as you go through and do these problems, here again is your process. If you're plugging in positive or negative infinity into a rational function, your first step is going to be to take a look at the rational function and look on the top and the bottom and see where the highest power of x is. In this case, it's on the bottom, and it is an x squared. So what we're going to do is we are going to multiply the top and the bottom by 1 over that value. In this case, our highest power of x is an x squared, so we're going to multiply top and bottom by x squared. When you go through and do that, we are technically multiplying, but you can think of it like a division step. It's actually a little bit easier. I'm going to take each of these terms and I'm going to divide it by an x squared. Mathematically, that's the same as doing this. So that's maybe a little easier way of thinking of that. I'm not plugging in infinity or negative infinity yet, so I still need this limit in front. The limit as x approaches negative infinity stays out there in front the whole time. You just keep copying it down until you do your direct substitution with negative infinity. All right, let's go through and divide each of these terms by x squared. So we would have a 2x over x squared. And then we would have a plus 1 over x squared. On the bottom, 3x squared over x squared. And then a minus 4 over x squared. So divide each of those terms by x squared. And then you should go through and reduce each one of those fractions. So again, I'm not substituting in negative infinity yet, so I'm still copying this limit down in front. Now I'm just going to do an algebra step, and I'm going to reduce each one of these fractions. So our first fraction here in the top is 2x over x squared. One of those x's on the top and the bottom would cancel out, so we would get 2 over x. In the next fraction, we have 1 over x squared. Nothing cancels there. On the bottom of our big fraction, we have 3x squared over x squared to start with, and those x squareds would cancel, which would just give me the number 3. And then the other fraction on the bottom, that does not reduce at all. Once you have gone through and reduced these fractions, that's when we plug in our negative infinity. So now I'm going to take negative infinity, and I'm going to plug that in for all of the x's. So I end up with 2 over a negative infinity plus 1 over a negative infinity squared on the top. On the bottom, 3 minus 4 over negative infinity squared. Now I want to take those 4 fractions and evaluate them. Our first fraction is 2 over negative infinity. That is 2 over a very, very big negative number, 2 over negative infinity. This is going to give me an extremely small number, and it's going to be very, very close to 0. So we're going to have something that is very close to 0. It's approximately equal to 0. It's not 0, but it is approximately equal to 0. So in my next step, I'm going to just use 0 to approximate this number. And then we have another fraction with an infinity on the bottom. In this case, it's a negative infinity raised to the second power. That's going to be very, very close to 0. And in the bottom part of the fraction, we have another fraction with an infinity down there. So that's going to be another number close to 0. So we have a very small number close to 0 plus another number very close to 0 over 3 minus a number very close to 0. Well, if you have two numbers that are very close to 0 and you add them together, you're still going to end up with a number close to 0. And 3 minus a number close to 0 is 3. So again, this is more of an approximation. It's not exact, but it is an approximation. 0 is a good approximation for how small that number is in each one of those cases. Remember that when you have 0 in a fraction in the top or the bottom, that does give you one of two different results. We can't divide by 0, so if we had a 0 in the bottom here, we would end up with an error, something that's undefined. But if you have 0 on the top, that's okay. 0 divided by a number is 0, at least if it's not a 0 on the bottom. So when we go through and evaluate this, we're going to go through the same steps that we did before. I said there were two different types of problems that we were looking at. In this particular problem, all of our steps were exactly the same as letter D. But what happened is we ended up with 0 here in the top part of the fraction. What I want to point out is this. As you go through and do this, this is a lot of work. That's more work than you do need to show. So as you go through and come up with your answer of 0, if you are for this problem, for a problem like this one, when you go through and you're doing these problems where you're doing limits of rational functions, this is a maximum amount of work that I probably would want to see. You could always show more, of course, but that's got a few extra steps in it. So let me just erase the things that I would not need to see so you can kind of see what I'm expecting in terms of work on a test or on a quiz. When you do this first step and you're dividing by your x squared, and then the next step when you're reducing, you can do that all in one big step. So if you want, you can show each of those, but really this first step that we did here, you could do 2 steps in one. And instead of dividing by x squared and then reducing, you can do that all in one big step. So when you have that and you're doing your dividing, you can simplify each one of those fractions before you write it down. Then I do want to see your substitution step. You can evaluate each one of those from there, though, without showing this fraction. So you wouldn't need to show me that fraction. So at a minimum, the amount of work I want to see is this. We're dividing everything by x squared, and if we reduce it right away, we get this. That's going to give me 0 plus 0, which is 0, over 3 minus 0, which is 3, and our final answer is 0. So that's the minimum amount of work that I would expect to see on a test or a quiz on a problem like that.